What concepts can you remember from your grade 7 physics class? In grade 7 physics, you have learned how to describe motion in one dimension using the different descriptors of motion, such as distance and displacement, speed and velocity, and acceleration. You also have learned how to describe motion using position versus time graph and velocity versus time graph. This school year, in your grade 8, we will learn. To begin with, we will answer the following questions. What do you think can cause a stationary object to move? What do you think can cause a moving object to stop? What do you think can cause a moving object to change its direction? To answer those questions, let's learn about balanced and unbalanced forces. What is a force? Force is a push or pull upon an object resulting from its interaction with another object. And its SI unit of measure is Newton, symbolized by capital letter N. Consider an object that is not in motion, like this ball on the table. Are there forces acting on a stationary object? Yes. The free body diagram of this ball shows that there is an upward force called the normal force or F sub n exerted by the table on the ball, and there is a downward force F sub g or gravity exerted by the earth on the ball. These two forces are equal and opposite in direction, and in effect, they cancel or balance each other, resulting to the stationary state of motion of the ball. So what happens when an object acted upon by two forces that are equal but act in opposite directions? Let's take a look at an example of this situation from the PhET Simulation Forces and Motion Basics. On one side, at the left side, 50 newtons of force is applied, while on the other side, another 50 newtons of force is applied. The result is a zero net force or sum of forces. What about if we increase both forces? Increasing both left and right forces to 150 newtons, still equal and opposite in directions, and you see that the cart is still in the same position. Let's take a look at the free body diagram of the cart. The cart is represented by the dot and the forces are represented by the arrow. For example, 50 newtons to the left and another 50 newtons to the right. Is it possible for balanced forces to act on a moving object? Let's take this example from the PhET simulation. Simulation. A cart is pushed to the right with a force that's enough to move it. Then, the applied force is gradually decreased until it is equal to friction force. With friction force and applied force being equal, the object now has an acceleration of 0. And if you will consider the free body diagram of the cart during the time that the friction force and applied force were equal, the result is a net force of 0. Let's summarize. Balance forces, or zero net force, refer to forces that are equal but act in opposite directions. There are also forces that cancel each other, meaning when the forces acting on an object are added, the sum is equal to 0. And when forces are balanced, the object is either at rest or moving with constant velocity. While it What happens to an object acted upon by two forces that are not equal? Let's take this example from the PhET simulation. Okay, this time the cart is pulled 150 newtons to the left and 350 newtons to the right. As a result, the sum of forces is equal to 200 newtons to the right, with the same direction as the bigger force. And we've seen that the cart also was pulled to that bigger force, which is going to the right. So looking at the free body diagram of the cart, it was acted upon by 150 newtons to the left and 350 newtons to the right, and as a result, the net force is equal to 200 newtons to the right. It was moving unbalanced forces, or simply called net force. Forces that are not equal, forces that do not cancel each other. So when the forces acting on an object are added, the sum is not equal to 0. When unbalanced forces act on an object, it changes its state of motion in terms of speed, direction, or both. We have learned already about balanced and unbalanced forces. Let's go back to the 3 questions that were asked earlier in the video. What do you think can cause a stationary object to move? What do you think can cause a moving object to stop? And what do you think can cause a moving object to change its direction? If you can answer these questions now, well, good for you. But if still your answers are not complete, then let's continue to learn more about the laws of motion. Zero acceleration, meaning it was moving with constant velocity. So balanced forces can act on a moving object, but the moving object has a zero acceleration or has a constant velocity. Two forces that are equal but act in opposite directions result to a zero net force. Thus, the object or the cart remains in place.